are about to witness the world's toughest team in action, a team directed by the Ballistic Systems Division of the Air Force Systems Command. Team members are the men of the military, men of science, men of industry and labor. Their goal is to deliver squadrons of ballistic missiles to our Strategic Air Command, so that SAC will have the tools to continue its role as the guardian of peace.
This is the story of a production line that spans our nation from coast to coast and border to border, transforming thoughts on blue line drawings into ballistic systems, blending ideas with steel and concepts with concrete to fortify with added firepower our Strategic Air Command, a vital part of the vigilant guard that watches over the free world. United States Air Force ballistic missiles, weapon systems, brought into being under the management of the men of BSD, the Ballistic Systems Division of the United States Air Force Systems Command. This is their story. To understand the workings of BSD is to understand how a ballistic system is acquired, the anxious days, weeks, and months until idea has become fielded weapon. The men at this meeting are involved in phase 1 of a ballistic system lifespan. They are a source selection board. Their task, seek out an industrial team to produce a missile and its supporting equipment. At their disposal is the world's greatest industrial potential. A list takes shape, a list of contractors who might measure up to the challenges that lie ahead. A list of national resources, human and material.
We know few of you have had previous experience in production of missiles. You'll need technical assistance and help in expanding your facilities. These are available, gentlemen. The Department of Defense has assigned the missile program top national priority.
So that competing firms will be on an equal footing, they are thoroughly briefed together at a single session. Then their detailed plans, ideas, and cost estimates will have the same due date in a bid to the evaluation board. The men on the evaluation board have the responsibility of determining whose proposals are best. Once their decisions are reviewed by higher headquarters, purchase requests will be initiated and production will start. With painstaking care, the board sifts through reams of figures, trying to combine the versatility of industrial giants with the specialized capabilities unique to certain small businesses.
They call any firm with less than 500 people small business. Well, as you can see, I have about 50 working here. We make this diplex coupler, just one of the thousands of precision parts that go into a missile. In order to get on the missile team, I went to the BSD small business office and told them of our capability. They directed me to one of their prime contractors whose requirements I might be able to help satisfy. You see, the big industry boys racing against time often find it's better to farm out some of the work. So while an outfit like ours can't be in contention for whole large systems, we can do a bang-up job on smaller component parts or subsystems. Sure, it's competitive, and once you're aboard, it's no bed of roses. The schedules are rough. But then again, what is there worth having that doesn't take a little fight?
A fighting spirit and teamwork on the job. Teamwork that carries over to the contracts office. Business runs on contracts. A missile must move on paper before it can fly. Labor joins the team, and a 10,000-mile production line starts to operate. Air Force personnel work side by side with contractors, and the design of a missile begins to take shape. Research and development, R&D, is the Air Force term for this phase of a missile's life. Hundreds of thousands of parts make up a ballistic weapon system, and the men of BSD have focused attention on quality assurance. An intensive program of laboratory testing ensures that each part will do its job. The severe strain of operational environments is simulated. The rigors of acceleration and shock. The extremes of temperature, the freezing cold of upper altitudes, and the almost absolute zero of space in the shadow of the Earth. The searing heat of the sun's rays encountered in airless space, and the destructive burning friction of re-entry into the Earth's dense atmosphere. This exhaustive program of tests is all toward one end, the attainment of a reliable missile, one that can do its job. It is technology in search of the ever-elusive perfection. At a point about midway on the eastern coast of Florida, ballistic systems get their flight time. This is Cape Canaveral, starting point on the Atlantic Missile Range. From these towering gantries and concrete blockhouses, missile contractors and the men of the Ballistic Systems Division continue the test program.
In a missile flight test, we obtain information that we can't acquire in any other way. A flight test here at the Cape is not an operational demonstration. Missiles flown here are wired for sound, so to speak. Telemetry equipment lets us know how each system is performing in flight. Downrange, we have a network of tracking stations located on a number of islands. When we run out of islands, ships and aircraft take their place. From these stationary and mobile tracking locations, we can monitor a flight all the way. Essentially, that's the goal of the flight test program, to develop the missiles themselves and to advance the state of the art.
To advance the state of the art, to move ahead in missile technology. Each flight test is more than an example of repeatability. Each flight has something new on board, some new test objective.
11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
This was just one flight test from the Atlantic Missile Range. There have been hundreds. Vandenberg Air Force Base, California, is to the total weapon system what Cape Canaveral is to the airborne missile itself, a further proving ground.
Here at Vandenberg, the complete weapon systems are checked out for the first time. This is where manuals and procedures are either verified or changed, where the complete weapon system must prove itself under simulated operational conditions. For the first time, Air Force men sit at the launch consoles and learn to understand and control what the scientists have created. SAC is represented here, so is the Air Training Command, the Logistics Command, and the Inspector General. Contractors are standing by to help solve any problems we might uncover at this stage of the game. It's a test of people, machinery, and procedures working as an integrated unit, with this objective foremost in mind. When the operational bases are ready, we must have crews to man them and foolproof procedures for the crews to follow.
Site activation is the Ballistic Systems Division name for building operational missile squadron facilities, complete with missiles and all supporting equipment. It is carried on concurrent with the flight test program and is perhaps the most grueling phase of the missile's young life. An extension of the factory into the field, the final assembly point on the 10,000-mile production line. Once ground has been broken, concrete and steel construction begins, and the basic facility structures start to take shape. Plans for missile sites are drawn up by civilian architectural and engineering firms according to BSD requirements. At each site, the construction itself is contracted for and supervised by a member of the Army Corps of Engineers who serves as a part of BSD. As deputy for construction, he is responsible directly to the Site Activation Task Force Commander, a senior Air Force colonel from BSD.
Our population will zoom from the 100 or so you see here now to over 2,000 when the associate contractors come aboard. They'll install the missile support system and hardware once the basic buildings are ready. You might say that we have all the problems here of a new city. Solving them is my job because our goal is completion on or ahead of schedule.
On or ahead of schedule. Long before associate contractors' work teams come on the site, their supplies begin to arrive. This is as planned, a buildup of thousands of end items that will become the missile's support equipment. Then the anticipated population increase takes place as hundreds of workers report in ready to do their jobs, to piece together the hardware, the plumbing, the wiring, and the consoles. There is nothing routine about installation and checkout of ground support equipment. More than 75% of the total weapon system's cost is here. If the men in the field run into trouble, if there is a production slowdown or a need for high-level support and action fast, this phone rings. This room is the command post at headquarters BSD. It is open and operating 7 days a week, 24 hours a day. There are other posts like this at all missile sites and as needed at contractors' plants.
Our job in the BSD command post is the assignment of specific problems to responsible individuals within the organization. This might mean summoning a group of senior officers for a high-level meeting at 2 in the morning, working around the clock with contractors, or merely seeing to it that an overdue package is air freighted at once to its destination. More simply, we are here to see to it that the 10,000-mile production line remains on schedule so that each missile site will be ready on the programmed operational date.
In another office at BSD headquarters, missile squadron maintenance planning is being considered.
SN5. Thank you. To be an effective deterrent, a missile must be capable of launching at a minute's notice. The logistic plan, which establishes the maintenance and supply system for the Atlas, has been implemented and is now in being. We are now checking and testing and refining this particular system. Constant checking and testing enables us to give SAC a capability to operate in the field.
Constant checking and testing. A preventive maintenance program carried out around the clock to keep each operational missile ready for action. When a faulty part is uncovered, a call goes out to the missile squadron supply depot, where 35,000 replacement items are stored. And in a matter of minutes, a needed part can be on its way to the site. This is the objective of all Ballistic Systems Division activities. Fielded missile squadrons in the hands of the Strategic Air Command. Atlas squadrons in horizontal readiness launchers. Some below ground level, hardened for additional protection. And soon advanced Atlas squadrons will be standing guard in super-hardened, inverted silos. Our other large liquid-propelled ICBM, Titan, will give additional power to our deterrent force. In Florida, Titan's two-stage performance was being flight tested, while at the very same time, across the countryside, operational base construction proceeded on an urgent 7-day-a-week schedule. And in California, prototypes of these facilities were verified by baptisms of fire. With the advent of improved solid propellant rocket engines has come an ICBM breakthrough, 3-stage Minuteman. Comparatively small, easier to maintain, and cheaper to produce, Minuteman will bring us missiles in great numbers, deployed in silos that are even less vulnerable to enemy attack. Profiting by lessons learned in Atlas and Titan programs, Minuteman has become the child of simplified and efficient automation. We have now accomplished 8 years of accelerated progress in the field of ballistic systems, and a bonus has been achieved. The infinite universe has at last become accessible to man. Boosted into flight first by modified missiles and soon by powerful rockets designed primarily for space exploits, we are entering a new era of enlightenment. How ironic it is then that this same potential in the wrong hands can scorch the earth. Part of the Air Force team, whose mission it is to help maintain the peace, the men of the Ballistic Systems Division, coordinating the efforts of millions of Americans, are determined to create and put into the hands of the Strategic Air Command a ballistic missile retaliatory force powerful enough to deter any aggressor, or in the event of a war, to prevail. This, then, is the Ballistic Systems Division story, a story that is still being written.